Hello, my name is Macy Hill, and today we're doing the equilibrium and Le Châtelier's principle. And there's going to be two parts to the Le Châtelier's principle lab. The first one is the equilibrium of chromate and dichromate, and the second one is the equilibrium of ferrocyanide and ferrocyanide. So let's begin. So as it says here, it says the potassium chromate is partially toxic. So I've cut open the potassium chromate, I cleaned the scissors, I got a new roll of paper towel, and now it says to place 8 drops of potassium chromate in a well directly in front of the pipette. So we'll add 8 drops into well B. So that should be enough. And now let's look at the next steps. So it says to record the color of the chromate in the well plate in data table 1. So as you can see, it's like a bright yellow color. So I'll record the color and we'll continue. So next it says to add 4 drops of hydrochloric acid, which is right here, to the potassium chromate, and this reaction will push the reaction towards the product, so the resulting color change should indicate the formation of dichromate. So let's do 4 drops. Of just hydrochloric acid. Alright. So the color has turned from a bright yellow to a bright orange. So I will put this into the data table, and then it says to add drops of sodium hydroxide to the chemical system until the color change is complete, which should bring the mixture back to the reactants. And then it says to record the number of drops of sodium hydroxide added in the resulting color change in data table 1. So we'll do that. So after adding hydrochloric acid, this is the color change, which is like a bright orange. And now we'll add drops of sodium hydroxide and see what color it makes, the complete color change. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It doesn't look like it's changing any further. It looks like it is reverted back to the potassium chloromate color. So when the reaction was pushed towards the products, it turned into a bright orange, and when it was pushed back to the reactions, it turned into a bright yellow again. So we'll add that to the data table and move on to the next step. So next it says to create some very cold water and some hot water. So I made a bath of hot water and a bath of cold water. So next it says to place 8 drops of potassium chromate into an empty well, and then add 4 drops of hydrochloric acid to the potassium chromate in the well. And then use an empty short stem pipette to draw all the potassium chromate / hydrochloric acids from the well, and turn the pipette over so all the reaction mixture is pulled at the bottom of the pipette. And then we observe the color change, and then put it into the reaction mixture into the cold water bath. So I'll begin the experiment. So I'll place the 8 drops into the D1 well, so it'll be easier to suck up the mixture using the pipette. So 8 drops of potassium chromate. And then it says to add 4 drops of hydrochloric acid to the potassium chromate well. So hydrochloric acid, 4 drops. And it should turn into that bright orange color. And then it says to use the empty short stem pipette to drop all the potassium chromate. And then it says to add it to the cold water bath. We need to submerge it into the cold water bath. And then it says to allow the remaining for 2 to 3 minutes. So I'll go ahead and tip it over and add to the cold water bath for 2 to 3 minutes. So in the hot water bath, the mixture solution turned yellow, while in the cold water bath has remained orange. So in the hot water bath, the mixture went over to the reactants, and the cold water bath it stayed at the product. So I'll put this down on my data table and show y'all. So based on our results from the heat test, we can infer that this reaction is an exothermic reaction. So here's my explanation behind it. So whenever the temperature decreases in the exothermic reaction, the heat travels to the right. So in the exothermic reaction, the heat is with the products. So when it's the bright yellow means that it's the reactants, and the bright orange means that it's with the products. So since it was a bright orange color with the cold water, it moved to the right. And when the reaction in the hot water turned to bright yellow, so when the temperature increased in the exothermic reaction, the heat travels to the left, so it turned into a bright yellow. So now we're moving on to the last exercise of the experiment, equilibrium of ferrocyanide and ferric ferrocyanide. So it says to place 8 drops of potassium ferrocyanide in the ether well in the well plate. So I'll add it onto well B. So potassium ferrocyanide, 8 drops. So it says to record the color, and so far the color is a greenish yellow. So now it says to add 1 drop of iron 3 nitrate to the potassium ferrocyanide and record the color change in data table 3. So this right here is iron 2 nitrate. And it says to add 1 drop of this. So it is turned well, it looks like it's turned into like a solid mixture. There's some like solid parts in here that are like black. They have black ends. And now it says add drops of NaOH to the reaction mixture until the chemical system shifts, as noted by the color change. And then it says record the number of NaOH. So right here is NaOH, sodium hydroxide. So I'm going to open this and then put drops in until it reverts back to a greenish yellow. So it seems like the black parts are still in there. I don't think that they're gonna further dissipate. So I'll record like how many drops I put in there and we'll continue with the experiment. So the experiment is over with, and the potassium ferrocyanide was a greenish yellow. The mixture of the product was it has some black participants in it, and I described it like being a greenish blue color. And after 28 drops of sodium hydroxide, it attempted to revert back to the color of the reactant. So potassium ferrocyanide, it's yellow, while the iron 3 nitrate is orange. And it tried to revert back to that color, but there's still some black residue left from the participant. So that's the conclusion of the experiment for this week, and I hope you enjoy the rest of your week.